everybody. Hope you are all healthy and safe at home. So we are going to continue with our section 9.7, curl and divergence. So in the previous lecture we had seen the formula for finding the curl of a vector field and also the divergence, and what was the motivation for the divergence to come into existence and all. So in this section what we are going to do is we are going to discuss about some physical interpretations of the curl and divergence. So when we talk about, we had seen that the concept of the divergence came into existence because of the thinking about the flux coming out of the surface, and in a similar manner we can see various interpretations for the calculation of curl and as well as the divergence. So let's move on to it. So let's see. The word curl was introduced by James Clerk Maxwell. He was a Scottish physicist, and he introduced the word in electromagnetic fields. But we use the definition, or we use the concept of curl mainly to understand the flow of fluids through various networks and all. So here you can see in figure 9.7.5 we have a paddle device. So the curl can be considered as the measure of the tendency of the fluid to turn this device. So if we are allowing a fluid to flow through this device, curl will be the measure of the tendency of that fluid to turn this device about the axis W. So if curl F is 0, then we say that the flow of fluid is said to be irrotational. So that is, there is no whirlpools or some anything that will which will cause the paddle not to rotate. So that is, there is a free flow of the fluid through that network. So we can see that if we consider if we have a paddle device which is shown in figure 9.7.5, it is inserted in a flowing fluid, then the curl of the velocity field F is a measure of the tendency of the fluid to turn the device about its vertical axis W. Okay, and if curl F is 0, then the flow of fluid is said to be irrotational, which means that it is free of vortices or whirlpools that would cause the paddle to rotate. So sometimes in some problems, application level problems, they will ask whether the fluid is irrotational or not. So you don't have to get worried with the terms. If we are asked to find whether the fluid is irrotational, we just have to find the curl of that particular velocity field that is given to us. And if that curl is 0, then it is irrotational. So in a similar manner, we had discussed about the concept of divergence. So in divergence also, we had considered it to be the fluid flow per unit volume out through a surface, right? So here we can consider that the divergence of a velocity field F near any point P is said to be the flux per unit volume. So we had discussed this term in the previous section. So it is the flux per unit volume. So if the divergence of Fp is greater than 0, then we say that at point P, that velocity field will be the source. It will be the source for F, as there will be there will be some outward flow near the fluid, because if divergence of Fp is greater than 0, there is some flow over there, there is some flux at that point, that is, there is some flow of liquid through that surface at that particular point. So we say that there will be a net outward flow of fluid near the point P, and that will be called the source. And if it is less than 0, that means there is no such flow outside the surface. So that means some fluid is flowing into it. So we call it to be the sink for the velocity field F. And if divergence of F of P is equal to 0, then there is no flowing inside or outside that particular point, through that particular point. So we say that it is not the source or a sink. So these are the terminologies, so just keep it in mind. That is, we are dealing with the flux per unit volume. That is, if divergence of F of P is greater than 0, then P is said to be the source. And because there is outward flow from that particular point, and if divergence of P, f of P is less than 0, there is no outward flow, that is there is some flow into that point, so that is at that point P is said to be the sink, and if it is equal to 0, then there is no flow inward or outward, so it is said to be there is no source nor sink near the P. So you can refer figure 9.7.7 to get a clearer picture. Now in terms of when we consider the divergence in terms of measure of rate of change of the density of the fluid, that is we are considering the rate of change of density of that fluid, or we can in other terms we can consider divergence of F to be the measure of the fluid's compressibility. So in those terms we can say that if the divergence is 0, the fluid is said to be incompressible. So again I'm telling you, again I'm repeating it, you can just remember these terminologies for application problems. If suppose you are asked to check whether the fluid is incompressible or not, we should not be blank, we must know that we just have to calculate the divergence of F, and if it is 0, then that fluid is incompressible. And similarly in electromagnetic theory, if the divergence is 0, we can say that that vector field is said to be a solenoidal. Okay, so just remember these terminologies. One is the concept of irrotational fluid, that is curl of F is 0 means the fluid is irrotational. And then if divergence of F is 0, we say that the fluid is incompressible, and if divergence of F is 0, we can also say that that particular vector field is a solenoidal. So based on this we can do some problems which will make the concept of the curl and the divergence more clearer. So we will discuss about that in the assignment section. So that's it for today's session. Thank you. Stay home and stay safe.